Prepare for a potential cosmic event of extraordinary proportions. Balu, the red monster star poised on the edge of the Orion constellation, is now sending ominous signals across the universe. Astronomers, using the James Webb Space Telescope, have discovered unsettling evidence about this massive celestial body. Renowned astrophysicist Brian Cox has issued a sobering warning. Could we be on the brink of witnessing a cataclysmic supernova explosion that would forever alter the night sky? Let's delve into the awe-inspiring tapestry of the universe, where stars are born, live, and ultimately perish in spectacular fashion. One star has recently captured both the fascination and concern of astronomers and the public alike. Balu, a red supergiant of immense size and ancient age. Positioned prominently in Orion, Balu's signature reddish hue and shifting brightness have long intrigued observers. Yet, recent developments have heightened interest in this celestial giant. As we explore Balu's nature, we may be on the verge of witnessing a monumental event in the life cycle of a star. But what exactly do these changes mean? Are we glimpsing the prologue to a cosmic drama of unimaginable scale? Balu is approximately 700 times the size of our Sun, a star so vast that if it were placed at the center of our solar system, its surface would engulf the orbits of Mercury, Venus, Earth, and Mars. This mind-bending size not only reflects Balu's physical characteristics but also indicates its stage in the stellar life cycle. As a red supergiant, Balu is in the twilight of its existence, a stage marked by expansion and cooling following billions of years of fusing hydrogen into helium at its core. While Balu is about 8.5 million years old, a relatively young age in human terms, it is nearing the end of its life in cosmic terms. The distinct red color of Balu, resulting from its cooler surface temperature, around 3,500 Kelvin, compared to the Sun's 5,500 Kelvin, serves as both a visual clue and a sign of internal processes at work. Intriguingly, historical records suggest that Balu wasn't always red. Ancient Roman and Chinese texts indicate that nearly 2,000 years ago, Balu appeared yellow. Only in the 9th century did Arab astronomers first describe it as red, a change signaling the star's evolution over time. Another fascinating aspect of Balu is its fluctuating brightness. As a semi-regular variable star, its luminosity waxes and wanes in a complex cycle. Historically, Balu undergoes a notable 400-day brightness cycle and an additional 5-year cycle, which has been documented as early as 1836 by astronomer Sir John Herschel. However, what makes Balu particularly enigmatic is its occasional deviation from these regular patterns, hinting at more mysterious processes occurring within. In late 2019, a sudden and dramatic change in Balu's brightness, known as the Great Dimming, attracted global attention. One of the brightest stars in the sky and a prominent feature of Orion, Balu unexpectedly began to dim at a rapid rate, becoming visibly fainter to the naked eye by early 2020. Yet, observing Balu's behavior comes with a unique challenge. Due to its distance of approximately 725 light-years from Earth, we are witnessing light that left the star centuries ago. This time lag makes it difficult to interpret present-day changes, as we are effectively peering into Balu's past. The Great Dimming highlighted the limitations of current astronomical observations when it comes to real-time monitoring of distant celestial bodies. Leading the investigation into Balu's dimming was Andrea Dupree, Associate Director at the Harvard-Smithsonian Center for Astrophysics. Using the Hubble Space Telescope, Dupree and her team observed variations in Balu's outer atmosphere over a 3-year period. Hubble's ultraviolet sensitivity allowed them to examine layers above the star's surface, revealing that material was moving at around 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Balu and formed a dust cloud, believed to have caused the dimming. Dupree's team estimated that twice the usual amount of material from Balu's southern hemisphere was ejected during this 3-month outburst, prompting questions about whether such a large mass loss could precede a supernova explosion. The relatively close distance of Balu to Earth adds to the intrigue. Any potential supernova would be visible from Earth, offering a unique opportunity to observe such a rare event up close. Yet the question remains: does the Great Dimming foretell an impending supernova, or is it simply an unusual episode in Balu's long life? Several theories have been proposed to explain these phenomena, but for now, the future of Balu remains a mystery in the vast, unfolding story of the cosmos. Proposes a stage in the cosmic explosion process, a theory that has gained traction due to the common belief that Betelgeuse, goo, is nearing a significant phase in its stellar evolution. Another popular hypothesis suggests that dust, potentially ejected from the star itself, could be blocking our view. Like other red supergiants, Betelgeuse is known to shed material, and it was believed that this material could form a dust cloud dense enough to obscure the star's light from our perspective. A third explanation considers changes in Betelgeuse's photosphere, the visible surface layer, that might alter its apparent brightness. In-depth research using multiple observational techniques has helped unravel this mystery. Spectroscopic analysis revealed a decrease in Betelgeuse's effective temperature, suggesting that the dimming may be due to a significant dark spot on the star's surface. This hypothesis was further supported by evidence showing that Betelgeuse's temperature dropped by at least 170 Kelvin during the dimming event, indicating extensive surface changes. Ultimately, the key to understanding this unusual phenomenon came from a sentinel in space: the Hubble Space Telescope. Hubble's observations revealed that Betelgeuse's dimming was likely caused by a substantial ejection of hot material into space. This material formed a dust cloud that obscured part of the star's surface, effectively reducing the amount of light reaching Earth. The dust cloud was believed to have originated from extremely hot plasma that erupted from a large convection cell on the star's surface, then moved through the hot atmosphere to cooler outer layers, where it condensed into dust grains, creating a cloud that blocked light from roughly a quarter of the star's surface. Hubble's ultraviolet spectroscopic observations, which began in January 2019, were crucial in piecing together the timeline leading up to Betelgeuse's dimming. These observations detected signs of dense, heated material moving through the star's atmosphere months before the dimming in December 2019. Several ground-based telescopes also observed Betelgeuse's brightness decreasing, particularly in its southern hemisphere. Initially brighter than the star's usual glow, this ejected material eventually created a dark cloud as it expanded outward and cooled. The theory suggests that this outflowing material and the resulting dark cloud caused the star's sudden dimming. The magnitude of this ejection is extraordinary, bringing Betelgeuse into the astronomical spotlight. The star expelled roughly 400 billion times the mass usually produced in a typical solar flare. To put this in perspective, this mass ejection is almost comparable to a supernova explosion, supporting the idea that Betelgeuse could be approaching a critical phase in its life cycle. Despite the dramatic situation surrounding Betelgeuse, the supernova scenario remains a topic of debate among scientists. Some argue that while the dimming event is intriguing, it may not necessarily signal an imminent supernova. Red supergiants like Betelgeuse are known to experience periods of increased mass loss and brightness variability without necessarily ending in a supernova. The star's fate will depend on various factors, including its internal dynamics and ongoing observations. Although the large-scale events observed with Betelgeuse are captivating, they also serve as a reminder of the dynamic and unpredictable nature of stellar evolution. As we continue to observe and analyze this fascinating star, we may uncover further insights into its future and the broader cycles governing the life and death of massive stars. The cosmic dance of Betelgeuse is far from over, and we are merely observers in its grand unfolding story. The ongoing saga of Betelgeuse offers a unique opportunity to deepen our understanding of stellar evolution, particularly the life cycles of red supergiants. While the recent extraordinary dimming event has indeed sparked interest and speculation, it's crucial to recognize that the star's story is far from complete. Here are some additional insights and implications of this cosmic phenomenon. The significance of Betelgeuse's dimming event. A glimpse into stellar evolution. This remarkable dimming event provides a valuable glimpse into the later stages of a massive star's life. Red supergiants like Betelgeuse are in a transitional phase, and understanding their behavior helps astronomers piece together the complex processes leading up to supernova explosions. By studying changes in Betelgeuse's brightness and the ejected material, researchers can better understand the mechanisms that drive these enormous stars toward their final act. Challenges and observational techniques. The time lag effect and the need for precise observational methods highlight the challenges astronomers face. The distance of Betelgeuse means that our observations are essentially viewing events in the past, making real-time monitoring difficult. Advances in observational technology, including space-based telescopes like Hubble and future observatories, are essential for tracking such events with greater accuracy and for potentially predicting similar occurrences in the future. Comparative analysis. Comparing Betelgeuse's behavior to other red supergiants and stellar phenomena can help establish patterns and predictive models for similar events. How does Betelgeuse's dimming compare to other red supergiants that have exhibited similar variability? Are there recurring themes that could indicate an impending supernova? Or is Betelgeuse an outlier with its own unique set of conditions? Future observations and research. Monitoring the star. Ongoing observation of Betelgeuse, using both ground-based and space telescopes, will be crucial in determining whether this exceptional dimming is a precursor to a supernova or a different stellar phenomenon. Future observations could provide more data on the star's luminosity, surface changes, and ejected material, shedding light on its evolutionary path. Theoretical modeling. Scientists will use data from Betelgeuse's recent behavior to refine theoretical models of red supergiant stars and their eventual transition to supernovae. This modeling involves understanding the physics of material ejection, dust formation, and the impact of these processes on the star's luminosity and structure. Broader implications. The study of Betelgeuse also has broader implications for our understanding of stellar populations and the life cycles of massive stars. Insights gained from this star can inform our knowledge about other similar stars and the frequency and types of supernova events across the universe. Public interest and education. Engaging the public. The dramatic nature of Betelgeuse's story has captured the public's imagination. Engaging the public through educational outreach, media coverage, and interactive platforms helps foster a greater appreciation for the complexities of cosmology and the dynamic nature of the universe. Citizen science. Encouraging amateur astronomers and citizen scientists to participate in monitoring and reporting observations can enhance the data available to professional researchers. Community involvement in tracking variable stars and sharing findings contributes to the broader scientific effort. Conclusion: a grand spectacle. Betelgeuse's recent unprecedented dimming event stands as a testament to the remarkable and often